In this video, I'm just going to real briefly go over the network topology for the OpenStack test cluster that we have in NB238. Um, so you guys that are used to topology charts probably think this looks a little bit weird, but I've basically converged a partial physical and the logical topology. So you can see up here we have the different link types, physical link, a VLAN link, and then GRE tunneling. So anything that's a solid line, regardless of color, is going to be a physical link here. So when we talk about this, we have the fuel network is one of the two networks in the deployment that have to be routable back to the internet. So every node is connected to the fuel master node, and that's what controls our OpenStack deployment. So we can add nodes, remove nodes, reconfigure nodes. That's how we push out what roles are going to be run. And it installs, it controls the operating system install and all the configurations on each of the nodes. It's also responsible for pulling down updates. So that's why it needs to be routable out to the internet. Next, we have the management network. And also on that physical link, we're going to have the public and floating, what they call the public floating network. And also our private network is going to be tunneled using GRE tunneling over that interface. So that will be here our public and floating on VLAN 102 and our private VM network on VLAN 103 for GRE tunneling. With that GRE tunneling, we really don't have to do any other configuration on the physical side. That's all happened by, or is all handled by Open vSwitch and the OpenStack configurations. And the GRE tunneling is much nicer than the OpenStack configuration with VLAN segmentation, because we don't actually have to create VLANs for each of the tenants. So in this case, we just have GRE ID that's handled automatically. As long as the switch supports GRE tunneling, it pretty much ignores that on the physical layer. And we have IDs 1 through 65,536, so we can have over 65,000 tenants. So you see the addressing information over here. This is just what I used, so none of this addressing information matters. It can be whatever we want. And again, we have the management, storage, and private networks. Those are all going to be internal to the OpenStack configuration, so those address spaces won't communicate with the rest of the network. They don't need to be able to communicate. The only two networks that need to be able to get beyond the OpenStack switch are the public and floating network and the fuel network. Both of them need to be routable to the internet, and the public and floating network needs to be accessible from every classroom that's going to access the OpenStack network, and also from the internet. So this is the terminology that OpenStack uses, the public floating network. So what this is for us is the public portion of that is just the IP addresses assigned to each of the servers that is routable to the internet and accessed from other portions of the network So that would be like the dashboard. That address is one of the public addresses. So can we access the OpenStack dashboard, log in and create, launch images, that type of thing. And then the floating portion of that address space is the address that is assigned to instances or virtual machines inside of OpenStack. And that's the address that you access the virtual machine with if you're using a PuTTY or an RDP connection. So of course that needs to be accessible, from other computers on campus. All right, so that's pretty much from the OpenStack side. You can see that I've got a number of services listed here. I talk about those briefly in the original networking topology discussion from the live presentation. So that video is available. I'm not going to talk about them here. One thing I will mention is that we do actually have 3 controller nodes and 6 compute nodes. So this is an actual, from the server standpoint, it's not a full representation. We're using 2 different switches for our storage network. You can see that these links are in it's a 2-link lag, so these are gigabit switches, so 2 gig lag. And here we have a 3 gig lag, and I've shown that in different colors, but of course, each of the networks here, we have the fuel admin or Pixie network, the management, it's the fuel network, management network, and the public network. I just show those in the 3 different colors because those are the 3 networks that are using that lag. So of course, any of those networks will use any of the links, determined by the hash algorithm for the lag. Here we are using layer 4 hash, and down here we're using a layer 2 hash. So everything inside of the OpenStack configuration, so not the link back to the sandbox and not the link to the workstations, everything else in there is running jumbo frames. So we do have a link from the primary switch back to the workstations in the room, so they disconnect from the sandbox network and connect to switches that have been placed through the room to connect back to here. The reason for that is because we're simulating basically internal access. So this, what they're simulating now, is what they would see in a production deployment from on campus or inside the classrooms. And here we're just routing back onto the sandbox network for connectivity to the internet. All right, so that's kind of the basic overview of the topology. It's fairly simple from the physical standpoint. Just a few VLANs to create, and the addressing, of course, is completely customizable. We can use whatever addressing spaces we want to for a production deployment. So pretty easy from the networking standpoint to deploy. All right, thank you for watching. If you want to hear a little bit more about the services, of course, you can watch the original networking topology diagram. Also, the dashboard overview video is pretty good for a little bit more of an explanation on how the different services work. Virtual networking, just a little bit touch on that. It's more of an overview of what you can do inside the 2 different dashboards. And then, of course, we have the new KVM demo video that I recorded, which is basically a condensed version of the KVM module in the Vert Admin 1 class.